Welcome to the video. In this video, we are going to look at problem number 39 of chapter 22. In this problem, they want us to look at figure 22.6.1, which can be found on page 681. Before we look into this diagram, let's first look at the subtitle and the equation that follows it. The subtitle says a point charge in an electric field, and the equation 22.6.1 is just the same as the definition of the electric field, which we saw earlier. So, as you can see, on this page, in equation 22.1.1, the electric field is defined by the electric force divided by Q naught. We can move the Q naught to the other side, and this equation would become the equation 22.6.1. Now, in equation 22.6.1, that Q does not have a subscript naught in it. But in any case, this Q presumably will be like a test charge, in that it can be mobile. With that in mind, let's now take a look at figure 22.6.1, the diagram on this page. And here we can see that there is a setup which creates an electric field. And there are oil drops in the space in between. And those oil drops will be created by an atomizer. In particular, you want to look at the oil drop in a space labeled as C. In the experiment, we are supposed to adjust the magnitude of the electric field so that that particular oil drop is suspended in the air. Now, if you think about it, an oil drop has a mass, and therefore it will experience a gravitational force. But since the oil drop is suspended in the air, that means there must be a supporting force that cancels the gravitational force. And that supporting force will be the electric force created from the electric field. And therefore, in our problem solving, on the one hand, we want to be thinking about the gravitational force. And on the other hand, we want to think about the electric force exerted on the charge because of the presence of the electric field. So let's repeat what we just talked about. On the one hand, the oil drop experiences a gravitational force. The problem did not give us the information on the charge that will be carried by the oil drop, which, by the way, is what we are supposed to find out. But since the oil drop is suspended in the air, which means the net force must be zero, we will then conclude that the unknown force must be an electric force, which will be equal to the negative of the gravitational force. And from here, we can plug in the expression for the electric force that we saw just earlier on the left-hand side, and on the right-hand side, we can plug in the expression for the gravitational force. Notice that in this expression, I have replaced the downward pointing direction by negative j hat. In addition, the problem says the electric field has a magnitude of 1.92 times 10 to the power of 5th, and the direction is pointing down. So let's plug that in, and from that equation, we can obtain the expression for Q naught. Now we need to do a calculation for the mass m. And since the problem gave us the radius of the oil drop and the density of the oil, we can use those information to calculate the mass of the oil drop. And here I have done a unit conversion so that the mass of the oil drop is written in SI. And if we plug that value back into the expression for the Q naught, we will obtain the value for the Q naught in SI. And by now, we can see that the oil drop carries a negative charge. But the problem wants us to find the charge on the oil drop in terms of E. So we have to divide that value by 1.6 times 10 to the power of negative 19th. And the result is essentially negative 5. And we are supposed to round it to negative 5 because the value E, or 1.6 times 10 to the power of negative 19th, is a fundamental value. And presumably, we cannot get fractions of that. So that is the final answer. And this completes this video.